Welcome back. In this lesson, we will create a distributed control. One controller each for the two mechatronic systems, the lift and the pusher. We need to split the controller into two. Instead of modifying the existing controller, we will copy it and remove the functionality from it that is not required. Let's copy and paste. It asks for a name. We will first do the lift control. Let's delete all the pusher related data from the interface and save it. Let's go to ECC and examine each state one by one. First, the init state. We will edit the init algorithm to remove the lines related to pusher control. Next, we examine the transition condition from init state to remove the check for pusher retracted. Let's now check the initial algorithm. No changes required here. Going back to ECC and analyzing the next two transitions and the lift luggage state need no modification as they deal only with the lift. And we are building a lift control. Since it is not the lift that is responsible for pushing the luggage, we will rename the state to luggage lifted. Rename the corresponding algorithm to luggage lifted as well. Remove the line related to pusher from the algorithm. How do we know when the luggage is pushed so that we can retract the lift? Maybe we can use the luggage lifted sensor. I'm not sure if this will work. Let's try for now. Retract the lift when luggage lifted is no more true. Now we edit the luggage pushed algorithm to remove the pusher related line from it. Similarly, update the transition as well. Let's save and build to see if any errors are shown. There are no errors. We will continue and create the controller for the pusher now. We will follow the same procedure now as we did for the lift control. Copy and paste the original control and give it the name of pusher control. Delete all the lift related data from the interface. Let's go examine the ECC and update the states and algorithms one by one. Update the init algorithm to remove the lift related lines from it. Update the outgoing transition condition to remove the condition for lift retracted. Let's update the initial algorithm. The only line in it is deleted. So we can as well get rid of the algorithm as it is not needed. Looking closely, we see that we need to go to push luggage state directly, because that is the only action pusher can do. Let's reconnect the transition from initial state to push luggage state. Delete the redundant lift luggage state and its related transitions. We will delete the related algorithm later. Click on the state and press delete. Update the transition condition. Change from luggage arrived to luggage lifted, as we need to push when the luggage is lifted. Update the push luggage algorithm to remove the line related to lift. Update the luggage pushed algorithm as well. And next, update the transition condition for transition from luggage pushed to the initial state. We can now remove the unused algorithm as well. Save the solution, build the solution, and check for errors. We see that there are no errors displayed. It's looking good. We will end this lesson here. In the next lesson, we will update our application and deploy the two controllers to two different devices.